In this segment, I'd like to talk a little bit about secure wireless authentication. We've already determined that WEP is insecure. Now we need to determine what we can use both at home and in the enterprise. Enterprise obviously being a much bigger problem, bigger issue, bigger challenge, because if we do it at home, we can use WPA, WPA2, and a pre-shared key and share it amongst the 2 or 3 or maybe even 4 or 5 users that we have on our home network. If we're in an enterprise where we have, let's say 400 access points and 8,000 users or 1,000 users or whatever else, becomes a little bit bigger situation, so that we really don't want to have a pre-shared key because it's going to probably stay secret for maybe a couple, 3 or 4 minutes. And if you don't use any type of authentication, that presents a problem also. So let's take a look at the objectives. Define wireless authentication. Wireless authentication, no different than any other authentication, is when you prove who you are. It's just how we do it. And again, keeping in mind that when we put a wireless signal in the air, anybody that's in range is going to be able to detect that wireless signal. And the range varies dependent upon the antennas, in a lot of cases dependent upon the passive gain of the antenna. So the signals are there. It's a matter of whether you can get them and make sense out of them. List and describe the different types of authentication servers. We're really going to be focused on here are TACACS and Radius. Explain the difference between the various extended authentication protocols, EAP. Some of them are, we say, okay, extended authentication protocol is going to be good. Some of them are not as good as others. Some of them are weak protocols. Describe the 802.1, it says I think it should be 802.1x, Authentication Key Management. How we're going to, or it is the 802.1i, key management with the way that keys are generated, and we keep track of them and manage to keep the keys private secret without revealing, well, that would be private secret, without revealing them. Understand exactly what authentication is and the types of credentials that are used to authenticate users. Wireless authentication, give proof that they are authentic, prove who you are, that you actually should have access. And what we are doing in the wireless access is to get access to the wireless access point. Lots of accesses there, or the wireless router. Keep in mind that when we use defense in depth, that this is not the only thing that the user is going to have to, or that the bad guy is going to have to be able to try to compromise. Once they get on the wireless access point, if they get on the wireless access point, then hopefully you'll have other security devices in effect to prevent them from actually compromising your resources. So here it says wired network devices are assumed to be authentic because they actually have to plug into the network. That obviously is not always the case. Somebody brings in their laptop and unplugs their own desktop, or there's a spare connection and they plug into the Ethernet. That's not going to be an authentic device. There are other security methods, port security specifically, layer 2 security, that will prevent those types of things. But it is a much more difficult problem to prove that the wireless device is actually authentic, and that's what this is about. How are we going to do that? Wireless authentication requires the device to be authenticated before connecting to the wireless LAN, and the default connection is open, where you only have to type in or tell it that you want to connect to a specific SSID. Open system, shared key authentication, we probably all use those. Shared key, where you put it into your wireless device, and then we give that key to the users that we want to be able to get onto our network. If you really want to be secure in your home network, you don't give it to people when they come in to visit. You type it in for them, or you turn on your guest network. AAA elements: authentication, authorization, and accounting. Authentication is when we prove who we are. Authorization, what we can get to. Can we get to that printer? Can we get to that shared folder? And accounting keeps a record of what you did. Accounting is what would be used in some circumstances, depending on how your network's set up. You might use accounting to actually charge the different departments for network use. Authentication controls access by requiring valid user credentials. Yeah, we do that when we log on to the network through Kerberos, our username and password, and that's what we're eventually going to get to in this one with the protocols that we use. Authorization, what the authority has, what the user can do, and accounting is the resources that you consume, what you actually did while you were on the network. Information can be in the AAA to find evidence of problems for billing purposes, for planning, kind of the things that we talked about a little bit earlier. Planning, when you see certain usage patterns or when you record that you're getting at the limit of something, you can then use your AAA, what you've actually recorded, your records, your logs, to go to management and say, hey, we need more of this resource or more of that resource. So it can be very helpful. We have AAA servers that perform the AAA functions, obviously, and they can provide, again, significant advantages in a wireless LAN. We can leverage them, the AAA servers, to record this stuff, to keep track of what's going on, because remember, on your router you're probably going to have limited or no storage, so it would be advantageous to have those records someplace else. The categories of credentials that we talk about: something the user knows, something the user is, or something the user has. And what we're talking about, that something you know, username and password. Something the user is maybe a fingerprint scanner, some biometric. And something the user has, in that case we're going to be talking about smart cards or key fobs, some sort of certificate that the user has that they use to identify themselves. If you're out driving, you would use your driver's license, for instance, to identify yourself. So we have those things. Passwords, something the user knows, secret combination letters, biometrics, the things that we talked about. The human characteristics that are commonly used: fingerprints, face recognition, handprints, eye scans, iris scans, retinal scans, voice recognition, a number of different things that can be there. Biometrics kind of tend to be a little bit expensive, although the price has gone down significantly over time. So much so that we're probably in the under $100 range for a lot of these. Let me get an image up here real quick. Did a search for fingerprint scanners, and you can see the prices. We have one here at Walmart for $83.35, a digital one, a Microsoft one at eBay for $20. These are used. These are going to be in the $70, $80, $90 range. Digital personal scanner here, $128, $31, $109, $39.95. So they vary in price. Digital certificates, asymmetric, private key, or public key, which has two keys, a public key and a private key. Obviously, the public key we use to encrypt, and anything that we encrypt with a public key can only be decrypted with the private key. And if we were trying to prove our identity, we would encrypt something with the private key, and anybody can then decrypt it with the public key, and then you know it comes from us because it was done with our private key. And we should be the only ones that actually ever have that. If private keys get compromised, that's when you really get into trouble. The keys are issued by trusted third parties. You can create your own certificate server in the Microsoft servers. You can just add it as a role for the server. Create your own certificates. They're not going to be trusted until you put that certification authority certificate in the list of trusted certification authorities. So we have those things. So digital certificates typically going to be issued by a trusted third party, and you have to pay for them, obviously. And then we can use them to prove our identity, much like you would use your driver's license, passport, whatever else. These are certificates, something that's issued by a trusted third party, and it has particular characteristics about us. Probably a picture that would allow somebody to say yes we are or no we're not. And this is a fingerprint, an image of a fingerprint scanner. Again, the prices have changed significantly on those things. In the ciphering, if we have different keys are going to be for the public-private key. So in this case, we have the private key. Now is the time, and this would only be done, quite honestly, in this method if you were trying to allow everybody to decrypt your information. So if we encrypt it here with the private key, then anybody with the public key, and anybody with the public key is anybody, can decrypt it. Typically what we're going to do is to encrypt it with the public, or excuse me, with the public key, and then send it to the individual that has the private key. And once it's encrypted with my private key, it can only be decrypted. I got those backwards again, didn't I? When you encrypt it with my public key, only I can decrypt it with my private key. If public to public won't work. Only if you do it, only from one to the other do those things work. In the authentication world, we have the certificate servers and then registration authorities. If you go to buy a certificate, there are a number of people that sell them, but they're probably going to originate from a central authority. We had a few months ago compromise of a certificate server. And once you have compromised a certificate server, it becomes a really big deal, because when you do that, then we can make everything valid. And once we do that, we can then start decrypting just about everything on Earth. When you get certificates, be sure that you protect your private key. You also should back up your private key. To do that, you can use Internet Explorer to export it, or you can use the certificates MMC of Microsoft to export it. The reason is the keys actually go into the profile. If the profile gets deleted, the keys get deleted. So whatever you're using it for will no longer be valid. If you've used that key to encrypt, if you have an encryption key and you've used that key to encrypt data, then you have some really cool encrypted data that's going to be encrypted data. So the information on the certificate: serial number, the holder's public key, the name of the certificate authority, the name of the holder, the identification, a number of different things that are there. Let me see if I can find one here and get it up so you can see what a key actually looks like, or a certificate actually looks like. The easiest way, nice blank screen here, the easiest way to get a certificate is Internet Explorer. Go to Tools, Internet Options, and once I got the Internet Options here, let's drag it in here, and we'll go into Content, and we'll see Certificates here, and we have the certificates that are here. I'm going to go to this one issued by Komodo for this is actually a certificate that is now expired, as you can see. that was an email signing certificate. So I can go into it and view and see the particulars of that certificate. It says is expired or is not yet valid, whichever that we talk about. And it says I have the private key that corresponds with this certificate, and I in fact do. And the issuer statement here, if we go to it, we're not going to wait, tells us about the certificate. Get back to it. The certificate's expired. We go to the details. We have the versions, the V3 version, the serial number that it talked about, the signature algorithm, SHA-1 RSA. The signature hash is SHA-1. The issuer in this case is Komodo, and it's a client authentication and secure email certificate authority for this thing. Valid from, valid to. The subject, and the subject in this case is going to be my email address. The public key, when you look at this thing, is just a bunch of hex. But it's a big bunch of hex. So we have the public key in this thing. So that's basically, not basically, that is what one looks like. And then we can go here and see the certification path, how it got issued, the user trust back to the Komodo certificate authority, and down here it says the certificate's expired. So it knows that this certificate is no longer valid. Let me get rid of this. Maybe get rid of this. So back to these, the things that are in there. You can see certificates on your own machine by going through Internet Explorer and looking at the certificates that are available to you. Digital certificates can be used for authentication in a wireless LAN. They can be used for authentication in a number of different places, and this depends upon unique identification of that digital certificate. We can be used to encrypt a number of different things. The public key infrastructure uses the digital certificates. The certificate authorities are trusted, and it's not a matter of just saying, hey, send me one. You have to prove that you are really who you are. I've had a couple of instances over the years where they got issued improperly, and those certificates are then withdrawn immediately when we do those things. They're used that verify and authenticate the validity of each party involved in a transaction over a public network. The server proves who it is, and we prove who we are, so that we know, the server's proving who they are, so that we know we're not connecting to a rogue server out there somewhere that's just set up to look like where we thought we were going, and that we really are going someplace where somebody's going to do something nasty like steal our credentials and then maybe compromise our identity. Currently no single standard for using PKI, although there kinda is a standard for issuing these things. The authentication server is the most common. Radius, Kerberos in a Active Directory is the one that's probably most familiar with. TACACS Plus, which is kind of think Cisco with TACACS Plus, and the Lightweight Directory Access Protocol, LDAP. Active Directory is actually based on LDAP, and many of these things are based on the LDAP protocol. It was developed many years ago to store databases on the internet. Radius, and none of these are brand new. Radius, the one that we still use, developed in 1992. Remote Authentication Dial-In User Service. What it was designed to be is a central authentication point for dial-in users. And if you had multiple sites, you actually could use this thing for multiple locations. It's not necessarily going to be a one-to-one relationship when we get there. High volume service control applications, dial-in access on a corporate network is what it was used for. We now use it for things like VPNs, and we can use it for the 802.1x protocol, which we'll talk about in a little bit. And there are videos. I've got a video in my YouTube channel how to configure 802.1x in both a Windows Server 2003 and a Windows Server 2008 environment. So the Radius client's dial-up server or wireless access point it's responsible for sending the user credentials and connection parameters to the Radius server. The Radius client is. When we do these things, the Radius client, we've got a couple of kind of an odd situation here. And again, let me see if I can get another little picture so that we can look at this. And when we're talking about these terms, maybe they'll make more sense. This one may have a little bit more than I may have wanted, but you gotta bear with the lines again. In this one, the supplicant here, the wireless station, this says authenticator. This would actually be the client. And then the authentication server is going to be our Radius server. So the supplicant tries to connect to the client. The client really simply relays the information to the authentication server, which then checks to see if that is going to be valid. If it is, it then sends the information back to the access point that says OK and back to the machine that says OK. So the supplicant is what we have historically called the client, which is going to be the laptop. The client, the actual client in this case, is going to be the wireless access point, and then the authentication server is still going to be our authentication server, the thing that we would think of as an authentication server. So the Radius client here is sending the user credentials and the parameters to the Radius server, authenticates and authorizes it. Picture here, so that we go the Radius authentication, the laptop goes to the AP sends the information. Let's see if I can go through this. More lines. I know you'll love those. So the Radius server 1, the user ID, Susan or whoever goes there. The authentication request goes to the Radius server, which then sends it to the user database, Active Directory, or whatever else. Authentication acknowledgement goes back to this thing, and it records it into the accounting database, and a lot of these things are going to be taking place simultaneously. And then we get the approval back to the laptop. Once we've done that, once we're on the network, we still are going to have authorization to get to the resources. So what we're doing here is actually getting access to the access point. It can be used in conjunction with VLAN tagging. Additional security allows a company to maintain user profiles in a central database. Central database, I guess the biggest one right now that's in use is going to be Active Directory, and the LDAP database is what is really significant there. And Active Directory is at its heart an LDAP database. Allows a company to maintain user profiles in a central database. Kerberos, developed by MIT. Yeah, Microsoft doesn't own it. Linux uses Kerberos. A lot of are used for authentication, and it's a pretty secure authentication protocol. Verify the identity of the networked users, because that's what authentication is. So when we prove who we are, Kerberos provides a ticket to the user, and the ticket contains information about the user, and the ticket has an expiration, so that it has a lot of characteristics that are going to be useful to us. And when the user wants to have access to a resource, to a network for a service, for a resource, it presents its ticket. Checks the ticket to see if it matches that resource, and verifies the user identity, and then it looks to see if there is authorization of this thing. Terminal Access Control Access System, TACACS Plus, is an industry standard, forwards username and password information to a centralized server. And most of these is what they're doing, is they're actually taking the information and checking a database to see if the user is authorized. Support thousands of remote connections. Supports authentication, authorization, and auditing. Difference between TACACS and Radius. Radius uses UDP. TACACS uses TCP. So they perform a similar process, but it's the same but different. They use different protocols to do that process. LDAP's lightweight directory access protocol. It's a database stored on the network of information about the users on the network. X.500 is the international standard that we use for these databases. So X.500 kind of is a X.500 is a database standard that we use in these things. So white pages look up some information by name, and yellow pages searches information by category. We can do a number of different things when we look at these servers. Lots of different information in them. What I've done here, jumped to a server, a machine, and what I've done is run a piece of software called AD Explorer so that we can take a look at some of the things we talk about when we talk about what's in an LDAP database. In this one we go to the distinguished name, and this is going to be what is in this thing. The distinguished name, the core, the update sequence number, when changed, generalized time, when created, update sequence number, those kinds of things. Let's go in here and see if we can look at one of the users here. Tech faculty. Let's look at this user. It says the account expires, the admin count, bad password time, the last time that the user typed in the password improperly, bad count, and down a country code, a number of things that are available. The last log on, when the user last logged on to the system, last log off, the directory string, log on hours, if we have the log on count. So it has a lot of information about the individual users. It just gives you an idea of what's there, the things that are available in that particular data. So let me get back to the presentation. So it contains information about users and network devices. We have computers in there. It contains information about all those different things. The ISO, the yellow pages, we could search by name, the white pages, or we could search by function in those. The information is in a directory information base, a DIB, and it has a tree called the DIT, the directory information tree. And each entry is a named object with a set of attributes. We've looked at the attributes. The named object would be the fully qualified domain name of that object. Doesn't define any representation for the data stored. The directory access protocol is that which is used to access the X.500 directory. LDAP is sometimes called the X.500 Lite because it lightweight directory access protocol. There is a directory access protocol, but it's too big to be used in the machines that we use. LDAP was designed to run over TCP/IP. LDAP is simpler functions, encodes its protocol and elements in a less complex way than the X.500, but it also is too big. Makes it possible for almost any application in any platform to obtain directory information. You probably can get it through a web browser if you need to. Used in the WLAN, authentication servers, and we've looked at a picture of that, can use it for retrieving user information, and many Radius servers interface with it with an LDAP server, and that's where we're going to store the information once the user proves who they are to say yes, come on in. And once we come on in, then we have to determine what they can actually get to. The authentication, and let me click through these, I guess, relatively quickly, but we have a single site deployment's the simplest, one or more radius servers accessing a centralized authentication database. Used when the WLAN users are all located in a single site, single location. We can have multiple radius servers accessing the same database. More difficult to scale when we talk about those things, and again we have authentication database here, multiple clients in this case accessing a single radius server, and you can have more than one client, multiple clients that can access a single radius server, and then the radius server is going to the single authentication base. We could also have multiple radius servers if we needed them. If we had a particularly busy network, we could do that. The distributed autonomous site deployment uses local authentication with one or more radius servers at each site, and the authentication database is replicated from one central site to each local site. In this case, if we have a breakdown of communication, then we're not going to have the latest updates to this thing. The radius servers perform the authentication and accounting activity. The advantage here, it doesn't rely on remote network connection, and additional radius servers can be added to the remote site. So in this case, we have multiple sites in these things, multiple sites, and we have an authentication database, and then the authentication database is replicated to our remote site. So we have a centralized master, and the copies are sent to the remote sites, and then the access points or the clients will go through the radius server at those locations. Okay, I guess it's done growing, so we can get back to this, I hope. Distributed sites with central authentication and security deployment have remote radius servers for authentication. The management advantages, the radius servers and authentication are all centrally located. The disadvantages depends on the reliability of the network connections in order to do these things. So in this one, we'll go back to and see if I can draw without making it go crazy this time. We have a single centralized database, and our distributed clients go through, get the radius server right, go through a single radius server. And again, you can have multiple clients on a single radius server. There's no one-to-one requirement for that. Distributed sites and security with centralized authentication deployment. The radius servers are at each site to perform the authentication, and the database is centrally located. So in this one, back to the drawing I hope, we have authentication database, only one of them, and then we have radius servers at the different locations that access that data. And then the clients go through the radius servers. In this case, the clients can get to the radius servers. If we have a breakdown in the internet, then they won't be able to contact the database. Different models to set this thing up, and this table summarizes the different methods to do radius. Extended or extensible authentication protocols are the ones that probably are going to be more and more useful. In this case, the management protocol 802.1x. 802.1x is an authentication protocol, and again, in my YouTube channel are a couple of examples on how to, and there are others, you don't just have to use mine. There are other examples across the internet how to configure 802.1x. Governs the interaction between the wireless device and the access point of the radius server. In this case, it was designed with flexibility. The different protocols can be used to support different authentication methods. Before we go through it, let me get a little image up, I hope, so that you can have an idea of the process that goes on in 802.1x. Okay, on this one, what we have, and kind of to give an idea of what happens in the process, is first of all, we have an EAP, Extensible Authentication, over LAN start, which we go to the access point. The access point then sends back a request for identity. The EAP response to the identity, EAP response from the, it says client, but again, this is the supplicant. Supplicant here, client here, and authentication server here. And it's then the client forwards it to the radius server. The radius server then checks the back-end server or Active Directory or whatever LDAP database. It sends a challenge back to the access point, and then we get another response that goes back, and then we either get a success or a failure. So this is kind of the process that goes on when we use the 802.1x protocol. So the flexibility, the backend database can be Active Directory, could be any of the other databases that it will interface with. Hashing is a one-way hash, creates a ciphertext from clear text. What happens is when we hash things, if we try to crack a hash, we don't reverse the hash by dehashing. What we do is create hashes until they match. Used for comparison purposes. This is what we just kind of saw. 802 association response between these things, the EAP request response, EAP, and then the radius gets into the business, and then the four-way handshake in this. Quick snipping tool, the four-way handshake. In this case, the AP sends a nonce. A nonce is a number used once. Value to the station. This is going to be us. So we're going to go across here, get the nonce. The station then sends its own nonce to the AP together with an MIC, including authentication, which really is a message authentication and integrity code instead of just a message integrity code. The AP then sends a GTK and a sequence number together with another MEC. The sequence number is used in the next multicast so that the receiving station can perform basic replay detection. And then we get an acknowledgement of these things. These are all sent as EAPOL keyframes, which means that they can be sent before the authentication actually takes place. Let's get rid of this thing and see if we can keep going here. There are legacy protocols, ones that are no longer used. In the EAP, we can use these for wired or wireless networks. The protocols include PAP, which was basic authentication. PAP was like nothing was encrypted. Challenge and handshake is the foundation of the three-way handshake. In Microsoft CHAP, we use Microsoft CHAP v2 if we're going to use these things. Still use it, but have vulnerabilities are EAP protocol MD5 and the Cisco lightweight extensible authentication or extended authentication protocol, LEAP. Strong protocols are transport layer security, TLS, and when you see TLS, think certificate. So it requires a public key cryptography such as the digital certificates, and it's tunneled with EAP, TTLAS, and protected Extensible Authentication Protocol. And it's designed to simplify the deployment of 802.1x. It's really not all that difficult. A number of steps involved, but it's not an extremely difficult protocol to deploy. It uses Windows logins and passwords instead of the digital certificates. Once we get all of the identification stuff happening, what really happens is you go in to start the system. The server identifies itself with a certificate, and then we are asked to log on with our username and password. The authentication key, once the device is authenticated, the next step is to enable encryption, a series of interrelated keys. And I've gotten some other images here to take a look at how this actually happens. It says Master Key, Pairwise Master Key, Pairwise Transient Key, and okay, so here Key Management is what this one is called. In this case, the supplicant and the authentication server authenticate. One of the last messages is sent from the authentication server, given that the authentication was successful, and it sends a master key. So we have the system. Let me get my freehand back. It's going to send us a master key, and it sends both the WN, the supplicant, the WN here, and the AP derive a new key called the Pairwise Master Key, the PMK. And what happens here is the authentication server derives the PMK and sends it to the access point. From that, we get the PMK is moved from the authentication server, and then the PMK and a four-way handshake are used between the wireless network, the supplicant, and the AP to derive, bind, and verify a pairwise transient key. So we're going to get these pairwise transient keys, and these are the ones that we're going to use actually for the encryption, and they're going to change as we go in time. The transient key actually is a collection of operational keys, and we're going to see an image of that here in just a second. So kind of the process, we get a master key. From the master key, the pairwise master key, and then the pairwise transient key from those. So kind of an overview of how we get to this. This just has the process, but it doesn't really give you an indication of what does what. All the other keys are formed from the master key, the starting point when we use these things. Using the 802.1x, the master keys, we've just seen that image. The master key is sent from the authentication server, radius server, to the authenticator, the access point. The master key is encrypted with an EAP packet, and the AP sends this packet directly to the wireless device without seeing its contents. So the pairwise master key, WPA, WPA2 personal uses a pre-shared key. Enterprise, the primary master key, or this pairwise master key, is used in the security models generated by the radius server and the device, and these things all originate from the master key. The pairwise transient key is generated by combining the pairwise master key with 4 pieces of data. The supplicant's MAC address, the authenticator's MAC address, a nonce, a number used once created by the supplicant, and a nonce, a number used once created by the authenticator. So we're hopefully, when we start getting these nonces involved, numbers used once, we're going to get some uniqueness about the key itself. The transient key is divided into 3 keys: the confirmation key, the encryption key, and the temporal key. So in this one, the master key, and I think we've kind of done that again, but I guess it can't hurt to do it more than once. So here we have 1, the master key is sent to the supplicant. 2, the pairwise master key is sent to the authenticator. It derives it for the authenticator. It doesn't know what's going on. We use the master key to create the pairwise master key. I know I keep saying primary. The pairwise master key is used to create the pairwise transient keys and on each of these devices, so that we wind up with the same keys on all the devices without actually sending them across the network. They're derived at the destinations. Pre-shared key is entered if we're using the pre-shared key is entered on the authenticator here, and then the pre-shared key is entered in the laptop. The pre-shared key again is going to be one that we would use. Let's see if I can do this. Guess not. Okay, we'll try to keep going here. So the pre-shared key, I don't want to do that. See if I can get my drawing back and will not make it grow again. But the pre-shared key, go back to the freehand here. The pre-shared key is entered into the AP, and then the pre-shared key is entered into the laptop, and that's what we need for the personal ones. The pre-shared key is used to create the pairwise master key, and the pre-shared key is used to create the pairwise master key on each of these, and this is again in the security model. The pairwise master key creates the transient keys, and this is what is used for the personal version of WPA, WPA2. Group keys are used for unicast transmission. Master keys are used for unicast, and group keys are used for broadcast. Group keys, everybody has the same group key, so that when you get the multicast, you can actually read the multicast. The group-wise master key is the starting point for those, and simplify a random number the starting point for the group hierarchy, and then we create the group temporal keys when we do these things. And this is again kind of a simplistic view. The group master key, finally get the group temporal keys when we do these things. The handshakes, exchange of information between the devices, the 4-way handshake, exchange of information for the master key, and we've looked at that a little earlier. The following tasks: it authenticates the security parameters that were negotiated. You have to agree on what security is going to take place. Confirms the pairwise master key between the supplicant and the authenticator. Establishes the temporal keys to be used in the data confidentiality protocol. So what we're doing here is getting our keys done. The 4-way handshake performs the first group key handshake and provides keying material to implement the group key handshake. Authenticates the group temporal key and is preceded by the 4-way handshake. And again, here we're going from the AP, pre-shared key 802.1x exchange, or the pre-shared key access point supplicant. The primary master key exists. Again, remember that comes from the authentication server. The nonce, the number used once, is sent, and the pairwise temporal key and the group temporal keys are sent, and then we send the acknowledgments back to do these things. So WPA, WPA2 are the ones that you want to use, and in an enterprise environment, 802.1x, a lot of people now are using captive portals. They work very well also, and they go through the web interface instead of having to log on when you start. Remember, 802.1x can be a wired or a wireless protocol. You can use it for port authentication on a switch, or you can use it to authenticate to an access point. WPA2, WPA2 Enterprise Security Models utilize the 802.1x credentials. Used can be passwords, biometrics, digital certificates, anything that you would use to authenticate to an Active Directory. LEAP manages port-based authentication. EAP, not LEAP. EAP manages the port-based authentication. Port-based authentication, we don't get anything until we actually prove that we can be on the network. After that, we can get an IP address. All of the transmissions take place across the magic wall through EAP traffic. EAP traffic is allowed before authentication actually takes place. Wireless devices, unique encryption key called the master key, and we've looked at that thing. So authentication to prove who we are. Authentication servers radius is the most common. Extensible Authentication Protocol helps make our enterprise environment more secure when we do those things. And the key management is based on the key hierarchy. And I didn't look at the key hierarchy picture. I have a picture, I think, of the key hierarchy. I had a picture of the key hierarchy. Nothing really dramatic, but master key, pairwise master key. From the pairwise master key, this represents the fact that it is multiple transient keys, so that the temporal keys can be used and discarded and keep going on. The key confirmation key, the key encryption key, the temporal key, when we do those things. So we have those, and with that, I will end because the presentation's over, and I would like to thank you for watching.